Now for a brief tour of Casa Shelton. That's right, there she is. Look at her, all beautiful. Oh yeah. She looks like she's hungry. You know what she wants? She wants somebody's food. Let's see, let the light correct because Cranky Pants. Yeah, he's asleep right there. Yeah, he's totally mean and totally a pain. And let me tell you, if I could bring him to class, I totally would. But let me see. I hear that cricket. Do you hear that cricket? The cricket's in there somewhere. That cricket is just begging to be fed to the lovely Lilith. Did I show you Lilith? Yeah, that's right. There's Lilith, looking all happy and hungry. Right there in the zombie apocalypse, still wanting her food. Oh, Lilith. We'll see what we can do. All right, Lilith, do what you do. This is AP Physics C Mechanics. I appreciate you guys being here today. Today, for our pre-video, I have set up an experiment. Experiment for you. I'm thinking I've got an inclined plane. I have propped up a spare piece of wood, and I've used an LED disco party light. That's right, disco party light as my thing to prop it all up with. And I have several objects that have the capacity to roll set up right here. First, I have not toilet paper. I know you were thinking toilet paper, but you know that's in scarce supply. I'm not about to waste it on some science experiment. But this is a roofing tape. It's used for like these screen porches, like I'm sitting in right now. You put it over the seams and it will prevent the leaks. Now, in this video I've got the edge of the tape right here. I'm hoping you guys will be able to see that, because you're going to need to figure out how many times this sucker rolls from the top to the bottom. You'll have to use the seam to do so. Now I'm going to start up there at the top and I'm going to allow it to roll to the bottom. And I'm going to give you a countdown, 3, 2, 1, 0, because I want you to know that you're watching this on YouTube, which means you have the capacity to, when I say 0, take a look at the scrubber. That's that little ball at the bottom, and figure out where 0 is on the old time clock there, and then carefully scrub to the end to figure out how long, how much time has passed from when I release it to when it makes it to the bottom of the ramp. You're going to need that time. So here we go. I'm going to start here right at the top. That seam is right there at the top of the ramp. And 3, 2, 1, 0. Alright. Now, you could argue that my hand was kind of in the way down there for that first run. But since I've already done an entire take of this, with the camera not rolling correctly, we're going to count that as trial number 1. Because I'm not doing this 4 more times tonight. Here we go. I'm set up at the top. I'm ready to go. 3, 2, 1, 0. Ah, that was a good one. You should have no trouble getting that data. And here's our last one. All right, I'm ready to go. You ready to go? I'm ready to go. 3, 2, 1, 0. All right. 3 pieces of data there. 3 time trials. Now, that being said, I have put a meter stick out front. Now, it's not a meter stick, it's a tape measure, and I know it's not in meters, it's in inches, but I'm not allowed back into the school, so we have to make do with what we have here at home, and that's what I have here at home. So, tape measure, 39¼ inches long, but that's what we got, so that's what we're going to use. Next, You know, I hear Gordon Ramsay is doing a master class on how to cook for everybody who's stuck at home now, having to make what they can. Which is great, except that when you go to the store and you're looking for something like, I don't know, spaghetti sauce, you'll probably find that there is no spaghetti sauce, but you can find diced tomatoes. What we really need isn't Gordon Ramsay telling us how to cook. What we really need is like the guy from Chopped, who, when you're given 5 random things in your cupboard, you have to figure out what you're going to cook. That would be the right kind of masterclass. Here's 5 pieces of whatever I've got in my cabinet. Let's make dinner. That would be appropriate. All right. We are going to use Hunt's diced tomatoes here. And the reason why I've chosen Hunt's diced tomatoes is because I have limited options in my pantry, but this is one of the options. Now, when you look at like the tape clearly looks like a thick ring. But this, it's soupy inside. I don't know that it has an appropriate moment of inertia, at least not a consistent one, because I don't know that all the stuff inside is of uniform thickness, nor is it of uniform density, nor is it all rotating at the same speed. You know, tell them what's happening with the soup stuff. That's why I got it. So again, I've marked it. I have a pen here, and in take number 1 and take number 2, I fake wrote on the top. Actually, no, I really wrote on the top. This time I'm really writing again. I'm just saying I'm going to fake write on the top. But I've already done this a couple times. So there's clearly a dot here. You see that dot? I'm going to put that dot right there at the bottom. All right, it's ready to go. I'm going to release the can again at 3, 2, 1, 0. You better be ready with that scrubber. 3, 2, 1, 0. That's trial number 1. Let's try trial number 2. Here we go. 3, 2, 1, 0. I think my hand touched it a little bit early, because I've been doing this for a little while. But I'm willing to try that again. This will be trial number 3, but trial number 2 is a waste. 3, 2, 1, 0. That one was good. I didn't even bother getting my hand over there. Here we go for trial number 4. 3, 2, 1, 0. Alright. 2 different rotating objects to which I think you should be able to find the moment of inertia. But wait, because you've been such a good class, I do have toilet paper. That's right. And it's so soft. It's like the bear stuff. I mean, bears would wipe their butts with this. This is the good stuff. This is not like the FEMA sandpaper toilet paper I've seen out there. This is the real thing. So I have colored on a little bit, but I'm still going to use it later, because eventually I'm going to need it. But here we go. We're going to try the toilet paper. That's right. Moment of inertia toilet paper. 3, 2, 1, 0. Something weird's about that toilet paper, huh? Something I think we're going to have to talk about, I think, in class. I don't know about you, but from my anecdotal research and having done this about 27 times, toilet paper seems like it's taking a while. 3, 2, 1, 0. I feel like I got lots of time to get over there and stop that toilet paper, even though I just missed. I hope you noticed I just missed. We're going to try one more time. This is it. Last time. Last run. This is good. 3, 2, 1, 0. Oh. Tape's in the chair. Tape's on the floor. Tape's rolling away. Toilet paper on the table. Alright. You're probably going to want other measurements. And I know you're probably just out there begging for them, because you know, it seems like just having the time and what a meter is might not be enough. So I'm willing to give you a measurement or two. What is that you say? You'd like the length of the ramp? Done. Length of the ramp. Length of the ramp, 36 inches. You're welcome. What? You will? Fine. Height of the ramp. I'm not giving you the angle. I'll give you the height of the ramp though. 5 1/4 inches. That's right, 5¼ inches. All right, fine, you got me. You do need the height down here. 3/4 of an inch. 3/4, that's 0.75 inches. You need that because you're probably going to want this angle. Now look, I am not going to tell you how to find the moment of inertia. There are a variety of ways at your disposal. I do want you to consider that neither the can, nor the toilet paper, nor the tape slipped on the way down. That's important. I am going to tell you that I gave you enough information to figure out the angle, the length of the ramp, change in height. And I think I don't need to say this, but I'm going to. You could probably find this information more than one way. Now, I plan on talking about this in class today, but I plan on knowing that you guys have spent a little bit of time kind of figuring this out. You know, I've kind of massaged the class times. You start this video in a few minutes, you end it, you'll have 10, 12 minutes, maybe even more to figure out, you know, a few things about this example. And then when we have our live session, I plan on, you know, talking to you about this. More importantly, I plan on questioning you about this. But I will say this, okay, just a few things between you and me, because we're the only ones talking here, because it's, you know, sometime during the apocalypse. I didn't give you the radius of any of these objects. And it's not because I don't want to. It's because you don't need it. I'm asking for the moment of inertia. The moment of inertia, I, is the variable here. You can't treat the toilet paper like it's a thick ring. You really can't. You can't treat the soup like it's a solid cylinder. You really can't. The only thing that might be close to a thick ring is the tape, which rolled away, and I'm not going to go get it right now. But even so, I'm not asking for a theoretical calculation. I don't have the mass of any of these objects. But I'll remind you, inertia, although it can be measured partially by knowing the mass and knowing the shape, inertia is about resistance to changes in motion. I've allowed gravity to attempt a change in the motion of these objects. They resisted. Your job now is to figure out how much each item resisted. I want I, in kilogram meter squared, for each of the objects that was just demonstrated. And I'm willing to wait until the class session starts, which is in only a few minutes. And for those of you who aren't watching this on time, well, phooey on you. Phooey on you. Well, this has been a lot of fun. This is Shelty Shell Dog signing off. See you later.